Okay, welcome back. So let's look at how we can create different types of data in Rust versus Python. We've already talked about integers, but let's just redo that for practice, and let's look at the other types. So we have x equals 5. That's an integer. Let's look at Rust. How would we do an integer in Rust? We would say let x equals 5. And the compiler, again, is going to infer that that's an i32. But remember, we have more specific control in Rust over what type of memory we would like to allocate to that value. So we could say let x equals an i64. So this would let us store a larger value. And you can see I've created a reference x here, and then I've changed this reference now to an i64. We could also let x be a unsigned value, like an unsigned 8-bit integer. And remember that our I values, the i32, i64, you can see here, here's all of our options. We have an 8-bit, 16-bit, 32, 64, 128. Our I values are all going to be signed, which means they can be both positive and negative numbers. And remember, we have unsigned value option as well here. So U8, 16, 32, 64, and 128 bit. And these hold unsigned values, which means they are between 0 and some maximum value. So for example, an 8-bit integer can hold 256 values. So an unsigned 8-bit will hold values between 0 and 255. So these are good for things like RGB data. So RGB data is normally stored as an integer, but in the value of 0 to 255. So you may want to use an unsigned 8-bit integer for that application, which will save memory on your computer. You won't be allocating 32 or 64 bits of data to something that could never be more than 255 in value. Same thing with people's birthdays. That's another good application for an unsigned 8-bit integer. People cannot have negative birthdays, and most people don't live more than 250 years. So those are our integers. So let's look at floating point values. So we have y. Again, in Python, y equals, we'll say 2.75. So in Rust, how would we make a floating point value? We would say let y equals 2.75. And this would cause the compiler to infer that as an F64 by default. But we also have the ability to tell the compiler exactly what we want, and we can choose either an F32, a 32-bit, or a 64-bit integer, floating point value, excuse me. Okay, those are our integers and floating points. Let's look at Booleans. So we have bool, b equals, we'll say true in Python. And of course we could have b equals false as well, true and false. And Rust is going to be almost identical. We'll just say let b equals true with a lowercase, and let b equals false. So that would be creating a reference b, setting it to true, and then creating a reference b, setting that false. So equivalent code, that's self-explanatory. And then finally, let's look at strings. So I might have name equals, put my name in here, Frank. And remember, you can put strings as both single quote and double quote in Python. So I could also have name2, this could be Frank. So these are both strings with Frank in there. How would we do that in Rust? Very similar. We would say let name equals Frank. Now, here's where things get a little tricky. So in Rust, we cannot use the single quote as a string declaration. A single quote is specifically for characters, which is a different type of data. And that type of data we don't normally have in Python. So normally if I have a character like mychar f for Frank, that's actually a string object. But in Rust, we would actually treat that as a character. So mychar, so let mychar equals f. This is a different data type than a string. You can see that this data type is a char or a char character versus this, which is an str, which is a string. Now, to make things a little bit more confusing on the Rust side, there's actually two types of strings. So this we'll circle back on this again. So don't get too confused here if you're struggling to connect it. But it's pretty simple. So we have two types of strings. We have an str, which is a string that is stored on the stack. And in order for that to happen, it must be known at compile time. So you can see Frank is known at compile time. I've hard-coded that in. Versus this toString here, you can see this is actually a different object, a different data type. This string is actually a capital string object, and this is, if you look at this, a growable string, UTF-8 encoded growable string. So this string object is stored on the heap, and it does not need to be known at compile time. So without getting too much in the weeds right now, just remember that this type of string needs to be known at compile time. You can think of it as hard-coded in your application, known at compile time. And this string does not need to be known at compile time, and it can be made mutable. And this is good for things that you might want to change in your application or things that you don't know during development. And again, if you have a single character in Python, that's normally treated kind of like a string object, versus Rust, which there's actually a completely different data type, a char or a char, and that's used with single quotes. So those are our basic data type differences between Python and Rust. So go ahead and practice with that, and I'll see you in the next video.